So now we're going to move on from simplifying rational expressions to multiplying and dividing rational expressions. And to be honest, multiplying and dividing rational expressions is just a giant simplification. So before we jump into these algebraic expressions, I just want to make sure that we're okay with multiplying fractions. So if I had a question like 9/16 times 8/15, what could you do? Well, one of the ways of doing this is to multiply across. You could say that 9 times 8 is 72, and then you could say that 16 times 15 is 240. Then you'd have to simplify this. So you'd be looking for common factors of 72 and 240. So let's try 72 divided by 8. So I'm going to pull an 8 out of 72, and then I'm going to, whoops, that would not leave you with 72. That would leave you with 9. And then I'm going to pull an 8 out of 240, and I'd be left with 30. Now I have that common factor, which would simplify to 1. But I'd have to keep going. What's something that goes into 9 and 30? Well, 3 goes into 9, 3 goes into 30. I've got another common factor, and I'm left with 3/10. That is one way of multiplying fractions, right? To do it, multiply across and then simplify. The other way, which is the way that we're going to do it with the algebraic expressions, is that we're going to factor first. So for example, I'm going to write 9 as 3 times 3. I'm going to write 16 as 2 times 8. I'm going to write 8 as just an 8, or an 8 times 1, because I could see that there's an 8 down here. And then I'm going to simplify the 15 to 3 times 5. The reason I'm going to do this is because I can now technically still multiply across. This is 3 times 8 over 2 times 8 times 3 times 5. It's just one big giant fraction, right? The multiplication just continues everything across. And saying that, using my rules for simplification, I'm also allowed to divide before I multiply because there's no plus or minus signs. So I could do 3 divided by 3 is 1. I could do 8 divided by 8 is 1. And then if I was to multiply what was left, I'd be left with 1 times 3 times 1 is 3. And then 2 times 1 times 1 times 5 is 10. I get the same answer, but it was easier for me to simplify, I feel. So now we're going to switch back to these algebraic expressions. And I'm going to say that when you're multiplying, the first thing you're going to do is factor and look for anything that you can simplify. Then you'll multiply across whatever's left and then just double check that nothing can be simplified further. So for this first question here, we have a numerator which can be factored, a denominator which can be factored, and then again a numerator and a denominator which can be factored. So this is why chapter 5 was so important, is because we have to factor so much. So in my numerator here, right, there's two terms. I'm going to greatest common factor out of c. I'm left with c times c plus 2. Same thing in my denominator. I'm going to look to see what I can do. There's two terms again, but there's no greatest common factor, and it's a difference of squares. So I'm going to factor it as c plus 2 and c minus 2. Then my numerator up here, it's a trinomial. So I'm going to look for two numbers that multiply to give me 4 and add to give me negative 4. That's negative 2 and negative 2. You could factor this as c minus 2 all squared, or you can write it as c minus 2 times c minus 2. Up to you. And then my denominator, I have another greatest common factor of c, and I'm left with c minus 1. Then, like I showed you with the numbers, you're allowed to simplify. So I look for anything that's dividing that's a common factor. So for example, c plus 2 divided by c plus 2 is 1. C divided by c is 1. C minus 2 divided by c minus 2 is 1. Then I multiply across what's left. I'm left with 1 times 1 times 1 times c minus 2. 1 times 1 times 1 times c minus 1. And the temptation is to keep going, but hopefully you know now, just stop. All right, let's look at this guy. So you could pause the video, give this one a go. I made this one much easier. So if you look at this one, you've got a difference of squares in your numerator, which would factor to m minus 4 and an m plus 4. And then nothing else needs to factor. How can you tell? Well, they're linear, right? The highest exponent on m is a 1. The highest exponent on m is a 1. So for this one, the only thing that I can simplify is the m plus 4 divided by m plus 4 is 1. And then again, multiply across. I'm left with m minus 4 over m plus 2. All right, that is multiplying, but we're going to continue on to dividing because dividing really is multiplying with just one additional step. So when you look at the steps, there's a step that says flip. After that, it goes factor, simplify, multiply, simplify. What does the flip mean? Well, division is multiplication in disguise, right? To divide, all you have to do is flip your second fraction. And then you change it to multiplication. And from there, it's the exact same as what we did above. So step number 1 is to step number 2, I guess now, is to factor. No greatest common factor. That guy's done. This one's done. The only thing I can do is greatest common factor my denominator. So I've got 5p plus 2 over 6 times 5 over, I can greatest common factor out of 3 to be left with, oh yay, 5p plus 2. These ones should give you good feelings. I find all of 6.1, if you factor incorrectly, you'll be like, nothing simplifies. Whereas if you factor correctly, then you'll notice that something goes. So for this one, 5 plus p plus 2 divided by 5 plus p plus 2 is 1. I'd be left with 1 times 5 is 5 over 6 times 3 is 18. All right, maybe pause the video and give this one a go. First thing I'm going to do is flip the second fraction. Now sometimes I will flip and factor at the same time, but not in this video. Okay, but if you feel like you can, feel free. Okay, so now that I've flipped the second fraction, I'm going to factor everything. So in my numerator, I can see that I can greatest common factor out of q to be left with q plus 2. Denominator is 5 plus q. Numerator, I could factor out a 3 to be left with q minus 2. And then denominator is a difference of squares, 2 minus q, and a 2 plus q. Whatever order it's written here, you have to put it here. Then you're going to look to see what can simplify. Now this is a q plus 2 and a 2 plus q. Are they the same? If I wrote this guy in a different order, it would still be q plus 2, right? So this one I don't need to do that. I could just say it divides to give me 1. But then I've got this q minus 2 and this 2 minus q. That felt really weird coming out of my mouth. If you know it, you can simplify by just taking out a -1 or simplifying it, dividing to get -1. Or if you want to show your steps, right, we're going to take that q minus 2, we're going to write it as -2 plus q so that we can factor out -1 to be left with 2 minus q. So I'm going to write this as q, because we got rid of that common factor, over 5 plus q times 3, I was just deciding how I was going to write this, times -1 times q minus 2, or you could just write -3. Sorry, 2 minus q. I'm so used to variable first. It feels weird doing that. And then I can simplify. So again, if you wanted to do it in the step before, boom, gives you -1, great. Or you can do it now, you're still left with -1. Then we're going to multiply what's left. I'm left with q times 3 times -1, which will be -3q. And then my denominator, I'm left with a 5 plus q. Awesome. That is it. That is multiplying and dividing rational expressions.